So for the first lesson of this equations unit, we're really going to be focusing on showing the proper work to keep the equation balanced and get your answer. Important vocabulary terms to know are, first off, equation as a sentence stating that two quantities are equal. A solution is the value of a variable that makes an equation true. Oftentimes we use the word solve incorrectly. We evaluate or we simplify expressions, and then when there's an equal sign, it's an equation, that's when we actually solve to get an answer. And then additive inverse, those are two integers that are opposite, and the sum of an integer and its additive inverse is 0. We're going to be using those to solve here. So how do I go about solving an equation? We use inverse operations to undo the other operations and get the variable by itself on one side of the equal sign. What is most important, you must do the same thing to both sides of the equation. So we know that you can look at a lot of simple equations and solve. Again, we are focusing on doing this properly. You've got to balance, right? If something's balanced on one side and the other, we have to make sure that if I add something to one side, I also have to add it to the other to keep it balanced. So first thing I'm going to do is I'm going to draw my line down my equal sign, and I'm going to highlight the variable so that I'm paying close attention to what side I need to be doing the work on. So on this side, I see that we are subtracting 15. The opposite to undo that would be to add 15, because this is negative 15 plus 15 cancels out to 0. And x plus 0 is just x, so we got the variable alone. If I've done this to the left side, I must also do it to the right side. So we're showing why we do the different operations we do, that we want it to cancel out, and we're showing that we're keeping it balanced on both sides. A lot of people forget this step. You have to show it on both sides. And then on this side, negative 43 plus 15 is negative 28. The other thing that you can do with equations is you can double check your work. Especially when you're working with negatives, it's very easy to make a simple mistake. So just taking a couple seconds to double check your work is really going to help you. So what we do here is we're basically taking this value, negative 28, we're plugging it in where x was. So we're saying, okay, negative 28 minus 15 should equal negative 43 if I did this correctly. All I'm doing is I'm plugging that into my calculator. Negative 28 minus 15, look, it did give me negative 43. We are not requiring that you do this checking process for every single problem. Really, we're just encouraging you to use your calculator to take 5 seconds to plug in and double check your work. All right, number 2. First step, I'm drawing my line down the equal sign. I'm highlighting my variable. On the side with the variable, we have adding 67. So the opposite to undo that is going to be to subtract 67, because 67 minus 67 cancels out to 0. We're left with y on its own. If I'm subtracting 67 from the right, I also need to subtract 67 from the left. Negative 53 minus 67 is negative 120. Again, just quickly showing you how you can double check your work. If you want to rewrite this as y equals negative 120, that means the same thing. And I'm taking that value and plugging it into where y was in the equation. So negative 53 should equal the y value of negative 120 plus 67. I'm just plugging that into my calculator. So negative 120 plus 67, does that give me negative 53? Yes, it does. So we did it right. All right, let's look at 2 more one-step equations, and then we'll move on to the 2-step equations. So I'm drawing my line down my equal sign. I'm highlighting my variable. When we have a number written right next to a variable, that means multiplication. So the opposite is to divide. Remember, algebraically, we want to get rid of using the division sign, so we're using fraction bar to show division. If I divide this side, negative 32.8 divided by negative 32.8, doesn't cancel to 0, it cancels to 1. So we technically have 1a, which I can just write as a. If I divide the right side, I need to divide the left side. And then I'm going to plug this into my calculator because it's a big number. And I get negative 15.6. And then the last one-step equation, drawing my line down the equal sign, highlighting my variable. We see this fraction bar, which means it's being divided by negative 2.4, so the opposite is going to be to multiply by negative 2.4. I'm using parentheses because I don't want to use x for multiplication. That looks like a variable, and a dot's going to look like a decimal, so I think parentheses is the best way to do it. The reason that this will cancel out is if we think of it like a fraction, that's negative 2.4 over 1, and these diagonals in a fraction would cancel out, you'd be left with m over 1, which is just m. So we are just canceling it out and writing it as m. Over here, we are multiplying by the same thing, negative 2.4, and when I do that, I get negative 28.8. All right, so those were some one-step equations. Now let's look at two-step equations. So the basic steps, which these could technically change, but more often than not, the steps to solving two-step equations, first, you should be adding or subtracting the constant, which is just the number, and second, you should be multiplying or dividing by the coefficient. So let's look. I'm going to draw my line down my equal sign. I'm highlighting my variable. On the side with the variable, I'm looking for my constant first. We're kind of starting furthest away from the variable and working backwards. So we've got negative 13. How am I going to get to 0? I'm going to get to 0 by adding 13 because negative 13 plus 13 cancels out. If I add 13 on the left side, I need to add 13 on the right side. Here's where I want you to be careful. Make sure you're paying extra close attention over here. This isn't 3x, it's negative 3x. So you're bringing down that subtraction sign and it just makes this into negative 3x. And then negative 55 plus 13 is negative 42. So a lot of people want to just write all of their work right here in one step. But that's not how you should be doing it. What I'm requiring you to do is you're showing your first step vertically here. You're rewriting what's left over in the equation, and then you're going to do step 2. X is being multiplied by negative 3, so step 2 is going to be to divide by negative 3 to get it to cancel out to just 1x. And on the right side, negative 42 divided by negative 3 is positive 14. So when you are doing this, I should see step 1, I should see you rewriting, and then I should see step 2, and then I should see your answer. That's how it should be set up each time. You're not doing it all up here in one step. All right, number 6. Drawing our line down the equal sign and highlighting our variable. Again, we are always starting with our constant. We've got a positive 7. We're going to get rid of it by subtracting 7 from both sides. 7 minus 7 cancels out to 0. We're left with 8d equals negative 51 minus 7 is negative 58. Now moving on to step 2, d is being multiplied by 8, so the opposite is to divide each side by 8. 8 divided by 8 cancels out to 1d, or just d. And then negative 58 divided by 8 is, if you plug it into a calculator, negative 7.25, or negative 7 1/4. Both of those would be fine. For these, when you are checking, again, we're not requiring that you write out the checking each time. We're just saying, okay, take a minute to plug it into your calculator, but I'm going to show you how you would do that. So a reminder, we would take our x value of 14 and plug it in where x is. So negative 13 minus 3 times our x value of 14 should equal negative 55. So I would check that into my calculator, and if I have a scientific one, I can do it all at once. So negative 13 minus 3 times 14, what does that equal? Whoops, I wrote that wrong. See, negative 13 minus 3 times 14 is negative 55. Perfect example why you should double check work. Over here, I would plug in 7 plus 8 times our d value of negative 7.25 should equal negative 51. So I'm plugging in 7 plus 8 times negative 7.25 equals negative 51. So again, you don't have to write it out each time, but take the time to just double check your work in the calculator. All right, I'm drawing my line down my equal sign. I'm highlighting my variable. On the side with the variable, I'm looking at my constant. I have negative 51.8. I'm going to get rid of it by adding 51.8. Those are additive inverses. They cancel out to 0. I'm doing the same thing to the other side. Now be careful. A lot of people get this one wrong. This is a negative x value, so you're bringing down negative x, not just x. And then over here, negative 38.7 plus 51.8 is 13.1. So really, when you're looking at this, this technically means negative 1 times x. So I'm dividing by negative 1 to get rid of that. Now we have a positive x value, which is what we want, and net equals negative 13. All right, number 8, drawing our line down the equal sign, highlighting our variable. On the side with the variable, we are looking at our constant. We have plus 16 or positive 16. We're going to get rid of it by subtracting 16 from both sides. 16 minus 16 should cancel out to 0. We're left with b over 4 equals 11 minus 16 is negative 5. On the side with the variable, it's being divided by 4, so the opposite is to multiply each side by 4. The 4's should cancel each other out. You're left with just 1b equals negative 5 times 4 is negative 20. All right, number 9, drawing our line down the equal sign, highlighting our variable. On the side with the variable, we're looking at our constant. We have plus 11 or positive 11, so we're going to get rid of it by subtracting 11 from both sides. On the side with the variable, it should cancel out. We're left with n over 3, and on the left side, negative 15 minus 11 is negative 26. Our variable is being divided by 3, so the opposite is to multiply by 3. It should cancel out on the side with the variable to be left with just 1n, and then negative 26 times 3 is negative 78. And last one, drawing our line down the equal sign, highlighting our variable. We look at our constant first. We have positive 9.2, so I'm going to subtract 9.2 to cancel to 0, and do the same thing to the left side. Be careful when we're rewriting our variable here. That is a negative value, so we have negative n over 1.4 equals 5.1 minus 9.2 is negative 4.1. Our variable is a negative, and it's being divided by 1.4. So we're going to multiply by negative 1.4 to get rid of the negative and get rid of the 1.4. Because a negative times a negative is going to make that positive n. And then negative 1.4 times negative 4.1 is 5.74. And that's it.